Section 10.2, we're going to talk about two population means where we know the standard deviation for the population. Again, this is a little bit of an unlikely scenario, just like it was in Chapter 9 when we were testing hypotheses with one sample. But again, the calculations are fairly easy, so it's worth doing here in class, but it's not one that you're probably going to run into very often in the real world. So again, we have two independent samples. They must be simple random samples, and the population standard deviation this time is actually known. In order for this to work, the populations do need to be normally distributed. So unlikely situation, but again, easy to do the calculations, so we're doing it. The calculator function that we're going to use in this section is 2samp z-test. Okay, not to be confused with 2samp t-test from section 1. So do be careful when you're selecting from that tests menu. Our first example is 10.6, and we're testing two floor waxes. Okay, two competing floor waxes. We want to see which one's better. 20 floors of a building are randomly assigned to test each wax. Both populations have a normal distribution, and then we're given the information from the samples in the table here. So we have wax 1 and wax 2, and we have the mean and population standard deviations for both. So what we actually want to be testing is, does the data indicate that wax 1 is more effective than wax 2? So the table here is data for how long the wax lasts on the floor. Okay, so wax 1 lasted a mean of 3 months. Wax 2 lasted a mean of 2.9 months. So is wax 1 actually more effective than wax 2 at the 5% significance level? So with that information, we're going to identify our null and our alternative hypotheses. So really, I think it maybe makes more sense to start with the alternative this time. Remember, my strategy here for identifying these is always write out the claim, write out the opposite of the claim, and whichever one of those has equality in it, that's going to be your null hypothesis, right? So this time, the claim was that mu1 is greater than mu2. Okay, the mean time that wax 1 lasts is longer than the mean time for mu2. The opposite of that would be the less than or equal to statement, and of course the null hypothesis is always the one that's going to contain the equals, so that's why we have that there. So now we go to the calculator with our 2samp z-test. You're going to put the information in that was in the table on the previous slide. So if you need to back the video up a bit, or if you're looking at the slides that are linked in Google Classroom, you can do that, and what you should get is a p-value of 0.1799. So 0.1799 is higher than our alpha of 0.05. So in this case, we would choose not to reject the null hypothesis, and we would say that there is not sufficient evidence to conclude that wax 1 is better than wax 2. I know that didn't seem like very much, but really that's all there is to it. And if you're fairly confident in section 1, then section 2 shouldn't be any difficulty for you. It's just a matter of picking 2samp z-test instead of 2samp t-test, because we have the population standard deviation.